Have you ever had your code just stop? You're working with a linked list, you run it, and everything just freezes. It's a classic and frankly super annoying problem. Well, today we're going to tackle the two biggest reasons this happens: null pointer crashes and, you guessed it, infinite loops. By the time we're done here, you'll know exactly how to spot them and how to fix them. A skill that, trust me, is a game changer. Let's dive in.
You know the feeling, right? It's a developer's nightmare. You hit run, your console is just blank, but your computer's fan starts spinning up like it's about to take off. Your program is stuck. It's not crashing, it's just gone. You end up having to kill the whole process. When you're dealing with linked lists, this is almost always the signature of an infinite loop. This sneaky little bug that doesn't scream and shout, it just silently traps your code forever.
So let's unmask these two common list killers. They really come in two flavors: the loud, obvious crash from a null pointer and that silent, endless loop from a cycle. To make sense of this, let's just imagine our linked list is a simple chain of paperclips. You know, each one is hooked into the next, forming a nice, orderly line.
Okay, so a null pointer is like getting to the very last paperclip in the chain. There's just nothing after it. Now, if your code is designed to always grab the next one and it reaches that end and tries to grab something that isn't there, bam, the whole thing just breaks. That's your null pointer dereference. It's a loud, abrupt, unmistakable program crash. Now, a cycle is way sneakier. Imagine that last paperclip, instead of just ending the chain, is actually hooked back to one of the clips in the middle. Now what happens? If you were tracing the chain with your finger, you'd get to the end, which would just send you right back to the middle, and you just go around and around and around forever. That's a cycle, and that is exactly what causes your program to freeze up.
So here's what that looks like side by side. A normal, healthy list, an acyclic list, is linear. It goes from A to B to C, and then it stops. It has a definite end. It's predictable. But the cyclic list, that's a trap. Once your code hits node C, its next pointer sends it right back to B, and it'll just keep bouncing between B and C forever. This is where programs go to die.
Okay, so how in the world do we find a cycle if just traversing the list gets us stuck in it? It sounds like a paradox, right? Well, we use this beautiful, incredibly clever solution called Floyd's cycle finding algorithm. But most people know it by its much cooler name, the tortoise and the hare algorithm. Think of it like setting up a little race inside your data structure.
The idea behind it is just pure genius in its simplicity. We create two pointers. One of them is our tortoise. It moves slowly, very deliberately, one node at a time. The other is our hare, and it's fast. It jumps 2 nodes ahead with every single step. And this difference in speed, well, that's the secret sauce.
So here's how the race plays out. If the list is a straight line, no cycle, the hare is just going to speed ahead and eventually hit the null at the end. Race over. We know the list is clean. But if there is a cycle, both the tortoise and the hare will get trapped in it. And since the hare is moving faster, it's absolutely guaranteed to eventually lap the tortoise. When they finally land on the very same node at the same time, boom, we've just confirmed there's a cycle.
Now, this line of code right here, you need to burn this into your brain. It is the absolute key to making sure our detection algorithm doesn't crash. We have to check if fast is null before we try to check fast.next. Think about it. If fast is already null, trying to access .next on it is a one-way ticket to that null pointer crash we talked about earlier. This order, while fast and fast.next, it's everything.
All right, so finding the cycle is great. We've detected the problem, but our list is still broken, right? It's still a trap. So now we've got to go from being a detective to being a surgeon and actually fix it.
And the repair process is this really cool 3-step dance. So step 1, we run our tortoise and hare race until they meet somewhere inside the cycle. Step 2, and this is the magic part, we take one of those pointers, let's say the slow one, and move it all the way back to the head of the list. Then we advance both pointers one step at a time. The place where they meet this second time, that is the exact starting node of the cycle. And once we know that, step 3 is easy. We just find the node right before that starting point and change its next pointer to null. And just like that, the loop is broken. The list is fixed. So why are we spending all this time on this? Because linked list problems, especially ones about finding and fixing cycles, are a cornerstone of technical interviews. Mastering this stuff doesn't just show you can write a for loop, it shows that you can think about pointers, you can handle tricky edge cases, and you understand fundamental algorithms. It's a huge green flag for interviewers.
And here's a pro tip that will make you look like a rock star in an interview. A really common mistake is to check if the nodes have the same value, but you could have a list like A to B to A to null. The value A appears twice, but there's no cycle. To find a true cycle, you have to compare the nodes themselves, their actual identity in memory. So you write if slow is fast, not if slow.value equals fast.value. Making that distinction out loud shows a much deeper level of understanding.
When you're in that interview, you absolutely have to talk about trade-offs. Floyd's algorithm is just fantastic because it's O(n) time, it's linear, but it uses O of 1 or constant space. That's amazing. You only need 2 extra pointers. The other common way to do this is to use a hash set to store every node you visit. That's also O(n) time, which is fine, but it takes O of n space, and if that list has a billion nodes, that's a problem. Knowing when to use each approach is a huge plus.
So, let's put it all together. Here's your interview cheat sheet. Number 1, always guard your traversals with null checks. Number 2, state the time and space complexity clearly. Floyd's algorithm is O of n time and O of 1 space. Say that phrase. 3, actually say the loop guard out loud, while fast and fast.next to show you get the safety aspect. 4, explain why recursion is a terrible idea here. It would cause a stack overflow. And finally, number 5, make it clear that you have to fix the cycle before you can do other operations like reversing the list. Nail these points and you're golden.
So, what's the big picture here? Well, fixing a broken data structure is really just the beginning. It's about restoring order so you can then do something powerful with it. Once you have a list that's guaranteed to be safe and predictable, you can start asking the more interesting questions. Okay, we've fixed the cycle. Now, can we reverse the list? That's where the real problem solving begins.